Um, so, miscellaneous things. Remember, the survey is down during class. I've had several people ask me again where to find the password and user number that you need to complete the survey. You go into Blackboard, you go into our virtual class, you go to My Grades, and then you scroll all the way to the bottom and it'll say survey, and you go over to the comment field and you'll see a 3-digit number followed by a colon. 3-digit number is your user number. What's after the colon, which is 7 digits, is your password. And it'll be up as of noon, but I don't want people doing it during class. Apparently no Quest access today, 2 to 4. They're doing something that they're undoing something. And remember, there is a Quest quiz with a due date next week. I think it's Wednesday, and it's no longer a minute before midnight. It's whatever day it's due, it's 6:30 in the evening. So next Wednesday in class, we'll have a new attempt at doing homeworks. So there are 3 articles up for this. Right, and so Article 1, 2, and 3, I'll give you some pointers about 3. So, I mean Article 2. So Article 2 would be a bear if I had you read the whole thing, right? That would not be fun. All I want you to pay attention to in Article 2 is the abstract, which consists of these 4 parts. And then there's some additional information in this paragraph called study design. Focus on the template for homework 2, ideal design features. Identify the statements in there that sort of give you details about replication, randomization, blind, etc. And just focus on those, pull those out, and do that for the other articles too. But the other articles are kind of softer and so on. That's what I want you to focus on. You'll also need to know which model is being tested in some fashion. I will give you more detail probably on Sunday. I don't know whether else, should I send it as an email or just put it on our site? Okay. What? Can I do both? Sure, I think I can live up to that challenge. But I mean, at this point, I've never done this before, so I don't exactly know what form this is going to take. I got a rough idea. Likely, you're going to come, so we're going to come in, and start, and you'll have about 10 minutes. You don't get to look at the article while you're here. And you're going to be told, focus on this article, based on your EID, you're going to choose one of the articles, then you're going to go through and answer questions like, which statement applies to the protocol use, which statement applies to blind, etc. for your article. So there'll be something like 8 options there. You're going to have to pick out the one that applies to the article that you're responsible for. So you got to keep them separate in your mind to do it. And I don't know, we'll just see how it works. And today's the last day for challenges. Yep. No, I don't really care. I mean, having said that, if I get 40 people at 10 o'clock, but I do care. I do care. It's being recorded. I don't want people looking at this and deciding. If you want to show up at a different section, just ask me. That will I'll have an idea. You will not have the articles present. So you're going to have to distill them out, all 3 articles, and sort of keep them separate in your mind, and then come in and just, you don't have to write anything down, right? You're just going to have to remember, oh, okay, the article on whatever it was, shoe softness, I can't remember. How were the study people chosen or something like that. I'll give you more detail Sunday. Just right now, start pulling out things that are relevant to replication, blind, randomization, etc. And so here, there's like one statement in this whole paragraph, I think, that tells you something that's not in the abstract. And I don't care about dates of studies, things like that. So you don't have to memorize this, you know, matching according to gender, etc. Just look for things, you know, was a feature present? And as I say, I got to go through the articles. I got to figure out how to write these so that they're, for anyone that knows the article, it's, you know, it's obvious which choice to make. And it'll be done on a green form again. Okay. I guess that's it for that. And maybe it'll be a disaster. We can look forward to that. So where we are is we're in evaluation, and we're focusing on correlation versus causation. Correlations can usually be graphed. So I'm going to give you 6 or 7 different graphs to illustrate different points about them. In all cases, the axes will be variable y and variable x. And so I don't want to label them on every graph. If you have something like this where the points are tightly clustered, and the way I'm always going to draw it is if the line's fairly steep, I'll make the points clustered. If the line goes up, we say it's positive. If the points are tightly clustered, we say it's strong. And to be honest, I don't know how much I've actually paid attention to this in the past. I suppose there have been some questions about it. This would be strong, but because it's in the down direction, we'd call it negative. And if we got points that are much more scattered, the line's shallow, weak, and since the line's going up, we would call it positive. You can figure out if the line's barely going down, we'd call it weak and negative. Then there's suppose the line is flat. We call that no or zero correlation. If you happen to have something like this, I'm going to draw it in the vertical plane, all the points lie on a line, right? There's no, so there's, in this case, there's variation in y, but none in x. Zero. So they mean the same thing. To say no correlation, zero correlation are the same. But this other one, which might be the same because you could draw the line horizontal too, it's undefined because there's only one variable. And graphically that looks easy, but figuring that out from words may not be as easy. Okay, now there's also correlations with discrete variables. And last hour I didn't explain this well enough. So let's say we have a correlation with gender. You know, could be hair length or something like that. So you'd have, you know, a variety of points there, and you'd have Unfortunately, one of us in this room would be down here. You know, and you'd have a scatter, but if the means are different, then you would say a correlation exists. But you cannot give it a sign. You cannot say positive or negative. And if you had something like this, again, two categories, and let's say the points did that, where there was no slope, there would be a zero correlation. So you can have correlations when they're categorical or discrete characters. Right? You just can't, in some cases there can be a sign, in other cases there can't. I don't know how much we're going to worry about that, but I do want you to realize that you can have correlations in this case, and if you were to draw a line through the 2 points, there's no, there are no actual data points in between here, but if you were to draw a line from this point to that point, if the slope is flat, we say it's no correlation or zero correlation. Okay, so now what I want to do is give you some questions from an exam last year, 2 years ago. And in some cases, there will be things on these options that we haven't actually gotten to yet in class. So you want that up there still? No, it won't work. So some of it will be legitimately confusing. Other parts of it you in theory can answer right now. So first of all, let's read what the question is asking. Which of the following statements describes a non-zero correlation? Do not choose any option that describes a zero correlation. That's straightforward. For which a correlation is undefined. That's straightforward. Or which describes causation but no correlation. This is the part I haven't really told you about, as to how we distinguish causation, a statement of causation from correlation. If insufficient information is given to determine whether a correlation exists, treat it as if there's no correlation. If part of a group is described as having some attribute, assume that others in the group do not have it. So we'll start with this one. Cultures with high dietary levels of red meat have higher rates of colon cancer than other cultures. So think about that for a minute, and then we'll switch to our cell phone interaction system. Think about whether you can graph it. Let me actually get this started, and I'll put the numbers on the board. Okay. So here we are. Following describes a correlation, and we're asking, is it true, false? So there's the statement again. I guess I don't need to show you the exam. True if you think there's a correlation, false if you think there's not. Okay, so most of you are on target. We're going to consider a follow-up to that. Oops. Actually, since you saw the answers last hour, I need to scramble these so that there's randomize them. Okay, so what I want to do is the following. You decided there was a correlation there. What I want to know is whether, if you were to graph this, which would be the correct way to put the axes. So we'll put here culture, red meat consumption, and you can still see, by the way, the description. So there's the statement of the correlation. We might graph colon cancer rate versus culture, or we might do colon cancer rate versus red meat consumption. So which graph you think? Actually, I should have given you the option of none, too. So there are your numbers to choose. So there's a description of the correlation, which I'm not even asking what the points would look like on the graph. I'm simply asking which axes would you choose to graph the correlation. Well, I clearly fooled you. Same thing happened last hour. Can't figure it out. I thought of this morning. Oh, I'll do this. Figured everyone would get tripped up. Didn't work. Okay. So, yes, you got the right graph. On average. Okay, let's go now to another one. And I don't answer it yet because I haven't given you the statement. Outdoor temperatures in Austin are cooler in December than in July. Does that describe a correlation or not? And I think in this case, let me just toggle back. 129. Okay, so for much of the rest of the questions, this is going to be the right set. And again, well, I'll keep that visible because one of the next ones we do, you're going to have to pay attention to what's actually being requested. But right now, we're doing what is called C here, but and I don't care if you talk about this. Actually, I don't care if you talk about the game this weekend or what else, but but think about how you'd graph it. This shouldn't be too challenging. We're slowing down. Okay. Let's try clearing those results and see who has the strongest arm twisting ability. Now I want to clear those again. Those 5 are probably late. So sit down and, well, you're sitting down. Okay, we got that. Step 1. Put a graph in your notes. Ask what's going to go on this axis, what's going to go on this axis. And then ask yourself, if I imagine points in here, do I have 2 variables? That's step 1. And second, if I put points in here, even though I don't know exactly where they are, if I know relative where they are, is there a correlation? Is anyone actually drawing a graph? How many changed their vote this time? How many didn't change their vote? I'd say you're not lying. Okay, this is good. I keep saying okay. I'm not going to say okay again the rest of this hour, like in Monty Python, Life of Brian. Except it wasn't okay. It was whatever he couldn't say. Right. Clear results. What? Give me one variable in this problem. What? Month? Okay. Okay, so December, July. What's another variable? There's a problem. So we have 2 variables. We agreed on that. So the only way we can get screwed up, i.e. the answer is false, is if the line we draw is flat. Because we know, so the problem says the temperatures change throughout the year and we've got 2 months. We have 2 variables. So what will it look like? relative. So if we have a set of points here, temperatures, what are they going to look like for July? Higher. Is that a correlation? It is. It's not positive, it's not negative, unless we somehow assign numerical values to these, but it is a correlation. A correlation means that if I tell you one variable, you know something about the other variable. If I say it's December, you know the temperatures are cooler than they are in July. And if I say it's July, you know it's warmer than it is in December. That means there's a correlation there. It kind of depends. So you're asking a fairly technical question. If the temperatures, say, did something like that, for the sake of this class, we'd say there's a correlation. If you actually did a statistical calculation, you might get a flat line, but I'm not going to go there, right? If there is an association such that once you know one variable, you know something about the other, we're going to say there's a correlation in class. So, okay, the next one is going to be one step more complicated. And you got to go back to this part of the question preface. Do not choose an option that describes a zero correlation, for which correlation is undefined, or which describes causation but no correlation. And I haven't told you, right? We haven't learned yet what causation sounds like, how to recognize it, but here's the option. Driving and talking on cell phones increases car accident rates, but drivers who talk while driving have lower accident rates than those who do not talk while driving. So what you're looking for here is whether there is a correlation described in the problem. And I'm going to clear out the thing. You're going to think about this a while if you're like the other class. We are not going to rush through it. So the same numbers as before. Feel free to look at your neighbor's drawings. Yes? For there to be a sign in the correlation, you have to be able to assign a value to both variables. So if you were to say December was month 12 and July was month 7, then you could actually have a sign to that correlation. But if you don't assign numbers to the variable, then you just say there's no sign. They both have to, both variables, so she's going into detail that I don't want you to worry about. But you have to be able to say that when you look at x and y, you have to be able to say this value of x is higher than this value of x, and you have to be able to do the same for y. And so with months, unless I assign an actual numerical value to each month, you wouldn't be able to say whether it's positive or negative. It's like gender. If I say number of X chromosomes present, then it's 1 and 2. Then gender can be, become kind of a numerical variable. But the rest of you can ignore that. So we're back to this one. We've got one result, one brave soul. How many want more time? So it's about 2 to 1 against. Not quite 50-50. Do you want more time to talk it out? You want to try again? You want to? Yes.
So when reading this, I thought that it might, like, is it on the test, would it be true if it was 2 correlations described?
Yep. So all you need is 1 correlation in the option. We want to try it again? Well, we got a few more votes here. Still about the same, 50-50. I sense a habit. Talk it out, see if we can resolve it one way or the other. Think about, look at the problem, can you pull a correlation out? What? Oh, you want to see the... Oh, it's meant to be talk on cell phones. It actually wouldn't change the answer you'd put down, but... Try putting a graph in your notes. Force yourself to say, can I yank out 2 variables? What? What? No, does not change the answer. It's what I just put up there is intended, but it won't change the answer. It's a little bit of a reversal. Someone give me one variable in the problem. Accident rate. Okay. What does the pattern look like that's described? This may be what's throwing you off. Okay. Well, this is plus minus. Or it could be continuous. You could put minutes talking on cell phone, something like that. Does not matter. Nor does it matter whether you graph it this way, on cell phone and accident rate. Doesn't matter. So, is there a difference? If I say, if someone is talking on cell phone, do we know something about their accident rate relative to someone who doesn't talk on cell phones? How many say yes? How many say no? Okay. Why do you say no? So, what's throwing you, judging from the discussion, is explained by the fact that I haven't told you how to recognize the distinction between causation and correlation. This first sentence, I can write on this now, or this first phrase, is a description of causation. It says, if you talk on if a person talks on a cell phone, their accident rate is going to go up from what it would be otherwise. This is causation. It says how you get there. This second phrase is a statement of, if we take drivers who talk on cell phones and compare their accident rates to those who don't, it does, it's going to be higher here than here. The second statement is correlation. Now, what's thrown you, and it's actually going to be a theme for the next week whenever we get to it, is that you're looking at a statement of causation and one of correlation, and they don't agree with each other. They're at odds. And it, in fact, can happen that way, right? A big theme here is going to be correlation does not imply causation. So you can, in fact, have causation going one direction and the correlation going the other direction. That's not what this option's about. It's simply about, can you separate a statement of causation from a statement of correlation, or in this case, can you look at this and just realize there is a statement of correlation in there? And there is. It's the second part. So it's not intended to be as deep as what we've just gone through. But a lot of you are confused because I heard people up front saying, well, they contradict each other. And they don't contradict each other because one is a statement of causation, the other is a statement of correlation. And we're going to spend 2 to 3 lectures talking about why they can go in opposite directions. No, it's true, because what you're asking here, so, and this, there's been plenty, even in 2011 when this was given, people were warned, right? Which describes a causation but no correlation. So in other words, if correlation is present at all in the option, it's true. But the reason it would have been easier on the test than it is for you is I've not told you how to recognize statements of causation yet, and that is what we will be doing. I want to do one more that is this one. So do you think this describes a correlation? 65% of the students enrolled in Bio 301D are women, 35% are men. I have to actually clear out this. Want to talk it out or do it on the board? Okay, give me a variable here. Okay, so someone put a point on the graph. How many data points do you have here? Really? So if you have you have two categories here, right? Unless you want to argue about transsexual. If you're 30, you basically 65% of one implies 35% of the other. You have one data point. You can't have a correlation with one data point. So that would be considered tricky if you weren't prepared for it, but now you're prepared for it. So the answer with that would be false. We're done for today.